Hello. Today we will be talking about the limit of rational functions, and specifically we will be talking about the limit of rational functions as x approaches infinity. With this topic, we have 3 different cases as well as some given solutions, and here are our given solutions. So the limit of f of x as x approaches infinity equals c. The limit of 1 over x as x approaches infinity equals 0. Also, the limit of 1 over x squared as x approaches infinity equals 0. And the answer 0 will be the same for the limit of 1 over x to any exponent that's 1 or greater. So our first case is where the leading exponent in the numerator and the denominator is the same. So the answer should be a ratio of the coefficients of that leading exponent. And here is how we find the answer. We are going to divide each term in the numerator and the denominator by the highest exponent in the denominator. In this case, it is x squared. We should be advancing our limits to be able to use the constant multiple rule and break up our limits as well as simplify. So here we get the limit of 2 as x approaches infinity plus 5 times the limit of 1 over x as x approaches infinity plus 5 times the limit of 1 over x squared as x approaches infinity all over the limit of 3 as x approaches infinity minus 2 times the limit of 1 over x squared as x approaches infinity. So here we finally get 2 plus 5 times 0 plus 5 times 0 over 3 minus 2 times 0, and in turn we get 2 over 3, which we should have gotten at the beginning. Our next case is where the highest exponent is in the denominator, and the answer we should get should be 0. So here's how we find it. We are going to divide each term again in the numerator and the denominator by the highest exponent in the denominator. In this case, it is x to the 7th. So again, we use our constant multiple rule and break up our limits and simplify as well. We get 3 times the limit of 1 over x squared as x approaches infinity plus 5 times the limit of 1 over x squared, x to the 5th, as x approaches infinity plus the limit of 1 over x to the 7th all over the limit of 2 as x approaches infinity plus the limit of 1 over x to the 6th as x approaches infinity plus 2 times the limit of 1 over x to the 7th as x approaches infinity. So lastly, it simplifies to 3 times 0 plus 5 times 0 plus 0 over 2 plus 0 plus 2 times 0, which equals 0 over 2, which equals 0, like we got at the beginning. And lastly, we have the case where the highest exponent is in the numerator, and the answer should be infinity, but we're going to check it and see what we get. Again, we are going to divide each term in the numerator and the denominator by the highest exponent in the denominator, which is x squared in this case. So here again we break up our limits as well as use our constant multiple rule and simplify. So we get the limit of x as x approaches infinity plus the limit of 2 as x approaches infinity plus limit of 1 over x squared as x approaches infinity over the limit of 1 as x approaches infinity plus 2 times the limit of 1 over x squared as x approaches infinity. So here we get infinity plus 2 plus 0 over 1 plus 2 times 0. So infinity is such a big number that the 2 really doesn't change it, so it stays as infinity. So we get infinity over 1, which in turn is infinity. So again, we have just talked about the limit of rational functions as x approaches infinity. Thank you.